Caitlin, whoever else is watching. Yeah, Greta says yeah, 3.2 is rough, right, James? See, you can vouch for me. It's rough. But when you solve it and you get to the end, it's like, yes, I did it. Because it's like you accomplished it. It's like this big puzzle, and then you've got to put all the pieces together and figure out what the value is. All right, so it sounds like I'm talking to myself today and chatting. I think with the live stream, you can see the chat too, so you can see what everybody's saying. Okay, so today we are going to talk about, well, first off, I sent you some more examples on 3.2 online. So if you get to 3.2 and you forget how to do it, there's more examples online, or if you're in 3.2 and you forget how to do it, there's a YouTube video out there that just shows me doing a few more problems. Also, this is a very common algebra thing. So if you looked up at Khan, I didn't even look, Khan Academy, you could probably find some videos of him explaining how to solve systems of linear equations. So yes, those are two options if you get to that. Or if you get to a problem and you're super stuck, you can always ask me and I'd be happy to do it. I actually did, when I first started teaching Algebra 2, I actually did all the problems in 3.2. So I can help you through any of those. So all that being said, does anybody have any questions over Chapter 2 test, Chapter 3? Nope. Not yet. All right. Well, I'll ask again at the end of class. So if you guys think of anything between now and then you want to go over, let me know. But just save yourself a decent chunk of time for 3.2. Just a little heads up there. Not that I want to inflict that on you, but it just takes a little while. Okay, so we are going to go over 3.3 today, and it's the perfect section for an online class because it is graphing systems of inequalities. Okay, so we have our graphing tool that we can do online, and then I think next week, let me double check here. Sorry for the crazy scrolling. Yes, next week we'll probably slow down a bit. So painting will have just 2 sections next week because they're a little bit tricky. So if you feel like, we're going really fast, we'll have a little time next week to kind of get caught up. Okay. That's how to make a high schooler's day, to tell them that we'll slow down a little bit next week, right? All right, so let's practice graphing a system of inequalities. Well, let's talk about what that is. So remember, system of linear equations just basically means that there's 2 or more equations that we're trying to make sure everything works for, right? Satisfies 2 or more equations. And when we have just equations and we have 2 equations, usually there's just 1 point. 2 lines intersect at 1 point. If you took geometry, you remember that. It's one of those postulates. But wherever our 2 lines intersect, that is the 1 point that makes both equations true. Well, in Algebra 2, we also study not just equations, we study inequalities. So remember, inequality just simply means that it's going to have greater than or equal to, less than or less than equal to. That's what inequality is, right? So instead of having 1 point on the line, there's many points either above or below the line. So I know back in Chapter 2, we talked about graphing inequalities. Well, now we have a system of inequalities. Not really many, yeah. So translation, equation. Is that what I sound like? Wah, 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 wah. Okay, so we studied how to graph an inequality. So now we have two inequalities, and we're trying to figure out what is true for both inequalities. So the first problem I am going to do without any of our graphing tools, because we're smart and we can totally graph, right? And then we'll kind of go from there. Okay, I have these grids down here, but that's not going to work. Grids. I'm trying to let me graph here. For some ever reason, whenever I go to draw on here, it thinks I'm not on the right thing. Come on, you can do it. All right, now I'm going to go really not technological here, and I'm going to just take a screenshot and go into Paint, because I know Paint will let me do it. Paint won't fail me. Okay, so we have two equations here. So let's figure out what makes both of these true. Okay, so we're going to call our top equation the blue equation. No, Greta says her computer is lagging. Greta, if you want to log out and log back in, you can do that. While you painfully watch me draw a coordinate plane. I suggest turning off Minecraft. Okay, so let's graph this without a graphing tool. We can totally do this. Y is less than or equal to 3x minus 2. Okay, so remember when you're thinking about graphing an equation or an inequality, we can think of it like graphing an equation. Okay, so our y-intercept, our plus b, is going to be at -2, right? This will be a good review for your test if you haven't done your test yet. And our slope is 3. So 3 means rise 3, run 1, right? Rise 3, 1, 2, 3, run 1. Rise 3, run 1. Okay, so this is the graph of 3x minus 2. And y is less than or equal to that. So since it has that less than or equal to, this line is going to be a solid line, right? And now I have to figure out which side of my line to shade in. Okay, so if you guys remember, we've done this before. Chapter 2. And then we used Desmos, and you guys forgot what I said, right? I know. This is what I'm saying. The graphing the line we did in chapter 2. Now we're going to graph 2 lines. All right. So you guys remember my trick. I know we've done this because I told you my trick. I always like to pick 0, 0 and say, okay, does 0, 0, does that get shaded in? Is it true or not? So if I put 0 in, 3 times 0 is 0. So what I mean here, let me write this out over here. Y is less than or equal to 3x minus 2. I'm trying to figure out if I shade in the left side as being part of my inequality or the right side. So I'm going to pick 0, 0. Is 0 less than or equal to 3 times 0 minus 2? So is 0 less than or equal to -2? No, that's not true, right? -2 is less than 0. So that means that my 0, 0 point isn't true. So that means that this side is my shaded in side. Okay, you guys good with that? And you can pick any point. I mean, I always just pick 0, 0 because I think it's the easiest, because when you multiply by 0, it goes away. So that's why I do that. But you could pick, 2, 2. And if that one works, then you know that you're on the right side to shade it. Excuse me. It usually means that, Elijah, but I think it's just easier just to check it because sometimes you get a graph and you're not really sure. Elijah's saying when it's greater than and equal, it means above the graph line. It usually does. Okay, so now not only do we have one equation, we have two equations. We have a system of equations. So now we need to graph the second equation, right? So by our awesome graphing skills, we know that if y equals negative x plus 4, we're just going to graph the line part first, right? Our y-intercept is, yep, this is basically overlaying two graphs. You're right, Elijah. So our y-intercept is 4. 1, 2, 3, 4. Right? And our slope is negative 1. So I go down negative 1 over positive 1. Down negative 1 over positive 1. Oops, I shouldn't have put a point there. Down negative. Okay, so this is my line of my second equation, my red equation, right? When I draw the line for that, is it dotted or is it solid or is it dotted? All right. Elijah says dotted. What does everybody else say? Dotted. All right. I got 2 dotted, so I'll take it. It's dotted, right? Because it doesn't have the equal part. So it can't actually be anything on the line. It has to be above or below it. All right. Daniel and James, thanks. And Elijah, the original dotted. Okay, so Elijah says, I think we shade above, which is probably true, but we can always double check, right? My good friend 0, 0. Is 0 greater than 0 plus 4? No, that's not true. So that means everything up here gets shaded. Okay. So now we overlay, basically what Elijah said, we overlaid 2 graphs, but what does that mean? So what values are true for both of these equations? So technically, the red graph is the, oh, sorry, Greta. So the blue graph, the first equation is graphed by the blue, right? And the second equation is graphed by the red. But we are talking about a system of equations. So we need to know what is true for both of these. So what you're going to talk about is the overlap. So red and blue make purple. Is that right? My art students. So anything along here plus anything along this purple line, and that's up in this quadrant. This is looking really messy. If you have nice colored pencils, it probably look way prettier than this. Is an acceptable answer. Is an answer to this. So if you try to find an answer to number 1 that's just like a 1 coordinate point, like 3, 2. I mean, there are lots of coordinate points that could satisfy this equation. Basically, anything that's inside of this purple area should be an acceptable answer to both of these. Okay, so I haven't actually looked in the back of your book to see how they graph it, but what you're looking for is the intersection of the 2 lines. Okay, so we should be able to double check this, right? Basically, anything I pick in purple should be true. So it looks like when x equals 4 and y equals 4, that looks like it's in the purple, right? So one possible solution might be 4, 4. And you can double check it. Just plug it into both of those and see really fast, right? Is 4 greater than or equal to 3 times 4 minus 2? That's a times, not a multiply. 4 less than 12 minus 2. 4 is less than or equal to 10. So it works in the first one. And then you can say, is 4 greater than negative 4? Oh, plus 1. I think I picked a point on the line. 4 is not just greater than 0. So apparently my line here would have hit right at 4, 4. So maybe I should pick 4, 3 because that one's clearly in the graph. So I messed up picking my point, but if I would have picked 4, 3, both of those would be true, right? Okay, so that's doing it by hand, which you guys all totally can do. You can also do this in Desmos. You can also do this on your graphing calculator, right? So let's switch over to there. If my computer will let me. There's my mouse. All right, Desmos. So what was my equation here? Y is less than or equal to 3x minus 2. And y is greater than negative x plus 4. Okay, so it's going to actually give you the same graph that we ended up doing in that picked red and blue and purple. I think I just switched the colors. So basically any point that's in this double shaded area is going to be true for both equations. So first off, I want to make sure that makes sense. Does that make sense that the overlay, the interception of both graphs is what is true for both inequalities? Yeah. This 4, 4 is tripping me up because it really should be on both of them. Did I do something wrong? Yeah. Okay. Everybody else? Nobody likes the purple. Just appreciate the fact that Desmos does this for you. If you have a standard graphing calculator, you can graph inequalities. And Daniel, remind me on Monday and I can show you how. However, when you did that on an old graphing calculator, everything was gray. So at least you get color. Okay, so let's try another one. I don't think this is, I don't think it's that complex, right? It's just figuring it out. Nope. Okay. So do you think we can do the second one without a graphing calculator? Think you could do it? Probably more neatly than I can. Do we have to find the slope of the line that is the area which is acceptable for both lines? Well, I was just showing you, like, your first instinct might be like, let me just plug all these into the calculator and get it out. But really, it's not that much work to graph it. I want to show that you have all the skills to graph it. Does that make sense? Yes. All right. So let's do number 2 quickly. I should have left my lovely coordinate plane up. That's not what I want to do. Okay. So let's graph both of these without our graphing calculator and then double check ourselves. So we have x plus y equals, or x plus y equals, x plus y is greater than negative 3. So we could rewrite that as y is greater than negative x minus 3, right? I just sent x to the other side. And then we are in y equals mx plus b form. So we know that the y-intercept is at -3. 1, 2, 3, -3 down here, right? And my slope is -1. Okay, so I didn't draw far enough down, but that means it's going to go down or this way, right? Because when we have our negative slope, it's going down. Okay, our inequality is y is greater than, so it doesn't have the equal part. So I know that it's going to be a dashed line, right? We went over that. And now I figure out which side is it going up or going down? We consider this sloping down, Elijah, in math. But if you're an optimist, you could say it's sloping or it's going up to the left, but typically we would consider that sloping down. The more you know. All right, so which side do I shade? My good point 0, 0. Is 0 greater than -3? So I am proposing that we shade this side of the equation. Does everybody agree with me? Because what I did is I quickly plugged in 0, 0. Is 0 greater than 0 minus 3? Oh, nope, that's not right. Let me unshade it. That was nice. 0 is greater than -3, right? So it should be shaded up here. That's why you should write it out and not just do it in your head, right? Okay, so now let's graph the second equation. So we have -6x plus y is less than 1. And if I send 6x to the other side, I have y is less than 6x plus 1. Okay, so my y-intercept is going to be at 1, positive 1, right? And my slope is 6. That's a really big slope. And I did not graph my scale to this, so I'm going to do 1, 2, 3.5. It's going to go like right here. And then 1, 2, 3.5 right here. Okay, so this also is going to be a dashed line, right? Because I don't have the equal sign. And now again, I have to figure out which side to shade in. So let me actually check my 0, 0 point. 0, 0 plus 1. So 0, 0 is true on this. So that means that this side is shaded. Okay, so then ultimately what I want to figure out is what makes both of these true. So it's going to be my overlap. I'm going to draw it in. I need a really bright color. I don't even have anything bright enough. Ultimately, it's going to be the line that follows here to where it intersects and the line that follows here, right? Anything along that line is not true. But then anything that's shaded basically to the right of those dotted lines should be true for both equations. All right, now let me read Elijah. He's typing furiously. But why? How can 0 be less than y? Furiously. Oh, in the orange equation, Elijah? Okay, so if I plug in 0, 0, right? So here was my orange equation. If I plug in 0, 0, I get 0 is less than 6 times 0 plus 1. That's not 60. So 0 is less than 0 plus 1. That means that 0 is less than 1. I'm just trying to, yeah, I'm just trying to figure out this point right here if it's shaded or not. I'm trying to figure out if 0, 0 is shaded or not. Because the line was a little bit to the left of it. Yeah, 0 is to the right of the line, right? So we're trying to figure out. Maybe 0, 0 was not a good one. So when we were back at which side of the orange line to shade, you could have picked like out here, this point right here, right? At 4, 0 was clearly to the right of the orange line. So let's try that. If we have negatives, or no, our equation was y is less than 6x plus 1, right? 0 is less than 6 times 4 plus 1. 6 times 4 is 24 plus 1. So 25 is greater than 0. So that would tell me that my right side is the side that gets shaded in. Okay, let me read again. Well, using the 0 as a cheat because anything. Well, it does not necessarily, Elijah, right? Because sometimes your graph will go the other way and it won't go through 0, 0. You can pick any point. If you don't like 0, you can pick any point. I don't know if I answered that all the way. But is less than, how can the shaded side be on the right? I'm not sure if I'm following Elijah, but I'm more than happy to figure it out with you. Let me switch over to Desmos and we can maybe my messy graph is the one that's what's throwing things off. So let me see if we switch over. So our equations were x plus y is greater than -3. Okay. And then the other equation was, and we can hide that one. The other equation, this is the one that was tricky, right? -6x plus y is less than 1. Just want to make sure I'm typing it right. Okay, so those are typed correctly. Okay, so when you're trying to figure out which side should be shaded, because what you're really graphing, right, is equal. And then you're trying to figure out when I put the inequality in, which side do I shade? So is a point over here true or is a point over here true? And I just personally pick 0, 0 because like I said, I'm kind of lazy and I like to divide by 0, but that doesn't mean that that's what you have to choose. So for example, I could say, okay, well, I've got this graph and I want to pick, if it will let me actually draw on here. I want to pick, sorry guys, this whiteboarding thing is not letting me do it. You can pick anything. How is a numerically larger number less than a line? The line length. It just all depends on the inequality. The inequality is what can throw it one way or the other. So you're trying to see like, math. I don't want to just say math. But you could pick, like Elijah, you could pick right here. Oh, finally it's letting me draw. -1, 1, right? So should I shade the left side where -1, 1 is, or should I shade the right side where +1, 1 is? So you have to see which one of these 2 points is true, and whichever one is true is the side that you shade. So if I have -6 and it's +1 for x +1, and my original inequality is what? Well, less than, okay? Is, oh, don't mess up because I'm there. Less than 1. So that would be -6 plus +1. Is that less than 1? And that's -5 is less than 1. So it looks like 1, 1 is true. So I'm going to assume that this is the side that gets shaded, right? If I plug in -1, 1, I get -6 times -1 plus 1 is less than 1. So I've got negative times a negative is a positive. So 6 plus 1 is less than 1. 7 is not less than 1. Okay, so Elijah, you're saying if I replace y with -1, okay, so this is y, or this is y at -1, and x with 1. So yes, if you replace that, then that's on the right side of your equation again, right? Y equals -1 and x equals positive, no. X equals +1, y equals -1 is right here. Right? So that again is on the right side and is what you would shade in on the right side. This is making sense. So when I do actually put in my inequality, it matches up with all of these points over here. Anything basically that's shaded in over here is going to be true for the second equation. The first equation, anything that's shaded by green, right? And so then when we overlay the two, everything that's in this deeper purple area is a valid point that is true for both inequalities. Now that does not mean you find out where they don't have a nice intersection. Anything on this line does not work, right? It has to be inside of this deep purple shaded area. Yeah, it can get tricky when you like try to think through it. It can definitely trip you up, Elijah. That's why I tend to just do the 0, 0 thing. But you could technically think through it and think what side is greater and less. It's those inequalities. Okay, so let's do the last 3. We're going to use Desmos for these. So let's just kind of, well, before I even graph them on Desmos, let's kind of look at it. Number 3 has y is greater than -2. So that one you don't need Desmos for, right? That just simply means what? Math. Why are you making me think, Mrs. Ross? If you've got a coordinate plane and you've got -2, that should be through here, right? Y is greater than -2. So that's pretty straightforward. That's what that's going to look like. Actually, I messed up because it's greater than. So this should not even be solid. This should be a dotted line, right? It's got to be greater than -2. And then we have overlaid on top of that, we have that y is less than the negative absolute value of x plus 2. Okay, so do you remember how to graph absolute values? Vaguely. Absolute values are going to look something like this, right? Or this. I just kind of gave it away that it's going to be upside down though because we've got that negative out front. So if we change over to our friend Desmos here, that looks lovely. I totally graphed that correctly, right? Y is greater than -2. That helps if you type it in correctly. There we go. So that was our easy graph, right? And there's our dotted line. We have Y is less than or equal to negative. What do we do? Oh, absolute value again. Put it in here, right? Absolute value of x plus 2. They even made it Halloween colors for us, right? Orange and black. Okay, so when we graph this is actually kind of cool for my artistic people out there, maybe. So what is the, ta-da, I know. So if you want to just graph what is true for both inequalities, I keep wanting to say equations, but they're not equations. If you wanted to graph what is true for both inequalities, it's going to be this cool looking triangle, right? Your graph would look like this. If you didn't have the other two on top of it, you would just graph a triangle. Two of the lines are solid, one is dotted. So really the only solutions to both inequalities are either what's inside this triangle or what lies along the top two lines. Okay, so right here, oh, don't scroll, right here in the center, right? Stop scrolling. Right here in the center is -2, -1. So that should be true for both my equations, right? It does look like a 45, 45, 90. You don't have to find the center of the triangle. I was just picking a point. You could pick anywhere. You can use Desmos and pick a point, right? It'll tell you. You can pick right, yeah. You can pick right along here, wherever you want to be. And could it be one of these along the line? Could it be -1, -1? It could be, right? Because that's a solid line there. Yeah, right, James. Yeah, that's exactly right. It can be. So if you remember my original equations, so look at that, it overlaid the graph. So the first one is y, come on, computer. The first one was y is greater than -2. So y is -1. Is -1 greater than -2? Yes, right? The second one is y is less than or equal to the negative of x plus 2, absolute value. Y is less than or equal to the negative of -2 plus 2. Oh, and this should say -1. So -1 is less than or equal to negative absolute value of 0, which is just going to be 0. So 0 is greater than -1. So that shows you that your graph is right because we picked a point right in the middle of the graph, right? We picked -2, -1, and it's true. It's a triangle? Okay. All right, 2 more problems, and guess what we're going to do? But wait, there's more. We're going to add even more equations. So what happens if you have 3 inequalities and you want to see where they all intersect each other? Can we do it? I think we can. All right, so let's minimize Desmos. I have x is greater than or equal to 8. X is greater than, and this one again, you should be able to do this. X is greater than or equal to positive 8. We know that's going to be at 8, right, over here. And it's everything that's positive past that. Okay, we have Y is less than or equal to -1. That's already those first two equations that we have, right? Whoa, hello. Somebody's mic just turned on. The first two equations constrict our answers to anything that's down in this box or below. Let me scroll out a little bit so you can see. Right? So we're already down with the first two equations to anything that's over here in the bottom right corner. So then on top of it, we're going to say, oh, and Y is less than -2x minus 4. Again, you could graph all these, right? You guys can graph these without Desmos. You don't need Desmos, right? Okay, so now we have to figure out where all three of these are true. It's going to make the really ugly color for my art people. So it's not until down here at, what is this point? X equals 8, Y equals -20. Ew, I know, ugly color, right? That all three of these equations are true. I'm going to need a bigger paper. So if I wanted to, that fail. If I wanted to, see my artistic people. If I wanted to graph my line, or graph where this inequality is true, it's going to be everything that's in this crazy looking triangle down here. Yes, a ruler would be way better than what I'm trying to attempt to do with my mouse on the computer. Okay, so then what does that mean? That means that anything in here should be true, right? Use a ruler on the computer. So I can just pick a random point in here. It looks like, and it could be anything. It'll work. Elijah's confident. See this point right here? It looks like, and I'm always picking easy numbers, right? 10, -35, because that's my goal. Make it easy, right? 10, -35, we say, is definitely true for all three equations. So the first one is X is greater than or equal to 8. Okay, so X is 10, so 10 is definitely greater than or equal to 8. Check that off. Okay, the next one, the next equation over here, right, is Y is less than -1. So -35 is definitely less than or equal to -1. So second equation works. Third equation is Y is less than -2 minus 4. So we're doing equation number 3. Oop, that's not what I wanted to do. Wherever we're at. Oh no. Come back. Where are we at? There, that's where we're at. Okay. Y is -35. So negative. The computer thinks I'm like switching panes or whatever they're called, Windows, whatever's on my computer. There we go. Just because I'm drawing a negative sign does not mean I'm trying to switch. -35 is less than -2 times 10 minus 4. Okay, -35. I'm just not going to draw that negative sign. Go back. I'm not hitting Alt. I'm hitting, I think when I swipe, I think it thinks I'm swiping right when I write the negative sign. I think it's just telling me to give up right now. I'm just kidding. Okay, so negative 35, and this is going to give me negative 24. Write a negative sign. It's not going to let me write a negative sign. Negative 25 is greater than negative 35. All right, well, that was a pain to check, but we got it. So here's what my graph would look like, and obviously you need some coordinates to go with that. Sorry for my technological failings there. All right, so then the last one, I actually think this one's actually pretty cool. The last one, we're going to have 4 inequalities to graph. So we need to see where all 4 meet up. So first we have x plus y is less than 5. We have x, and again, you guys can totally graph all these. X plus y is greater than negative 5. Okay, so already we're down to this little strip here, right? It's only in between these two. I say you can graph them yourself. You can graph them yourself. X minus y is less than 4. I'm saying you don't need Desmos to help you. Desmos is nice. It's a nice little tool, but you guys know how to do it without Desmos. Is greater than negative 2. Okay, isn't that beautiful? So what does that tell me? It means that, see this crazy looking rectangle here? This rectangle, inside this rectangle, all 4 inequalities are true. All right, your QB. Hey, guess what, Elijah? 0, 0 is inside the rectangle. I know. But there's lots of other points that are in there too. I don't know if we had a problem like this. So basically, anything that's inside this rectangle is going to be true. Okay. So I don't really have 0, 0 is the one clear point that I see is in both of those. Oh, it looks like 1, 1, 1 is in, oh, there we go. That's better. 1, 1 is inside there, right? So maybe 1, 1 will be less painful. So you can go back and check, does 1, 1 satisfy all 4 equations? So 1 plus 1, that's less than 5. 1 plus 1 is greater than negative 5. 1 minus 1 is less than 4, and 1 minus 1 is greater than negative 2. It's actually kind of fun, right? You get to make these cool graphs. It's way better than black and white and gray that I used to have to do. All right. So really the point of this section is not to just torture you with graphing. It's for you to understand the inequalities. We treat them kind of like graphs, right? Just regular lines. But really, we can look and see which values make both inequalities true, and it's not just going to be a single point. Okay. Thanks for bearing with all the fun today. Does anybody have any questions that they want to go over? You guys, your brains are done. How many problems like this? I don't remember what the homework is for this. I'll have to look. Just make sure that you print off your graph paper so you don't have to painfully draw graphs like me. All right, guys, thank you for sticking with me this week. I know we covered a lot of material. Hopefully it's all making sense. A lot. Good deal. All right, well, thanks, and I'll stay on if you have any questions. If not, have a good day, guys, or good weekend. Hope you guys get to do something fun. Thanks, guys. See you later.